My name is Julien Launay, and I'm the CEO of AdaptiveML. I think we're waiting a second for the slides to come up. Yep. Oh, and now we are a bit ahead. So at Adaptive, we empower enterprises to build better AI agents by giving them the tool to run reinforcement learning to build specialized models. Obviously, it doesn't escape to you that there has been a lot of hype and excitement around AI agents recently. Fundamentally, AI agents are able to use tools during their reasoning to access new information and to take new actions into the real world. And this is really a different shift that allows us to move from models that are like purely assistants, that are purely like copilots, to models that can actually take action and actually complete tasks by themselves, which obviously is really exciting in terms of creating actual value in companies. And I think we have all actually been exposed to these models, especially if you have used ChatGPT, for instance. Recently, a big improvement that you may have noticed in GPT-5 is that it doesn't answer in isolation anymore. It's going to do web searches, it's going to do execute code, to help better figure out the answer, all of that sort of stuff. This agentic behavior at Adaptive is what we help enterprise bring to their own use case. So instead of using a generic search, we are going to connect to the documents, to the databases that the enterprise have, help the model, use the tools, the APIs that are unique, like a flight rebooking or that sort of stuff. One thing that's interesting to note is that this is more than just, obviously we hear a lot about agents for a while, and some of it, has been a bit iffy, I think. If you have been around for a few years, you might remember stuff like baby AGI on GitHub, which wasn't really great, was early work of this. But one thing that's interesting is to see that in recent months, models with agentic capabilities, so combining reasoning and tool use, have actually been able to achieve, to change the trend in terms of how a model progress. So this is a plot with data from Meta about how complex of a task can models perform. And there is a change in the trend of progress with reasoning and tool use, with models now progressing much faster and completing much harder tasks, which is obviously very valuable because this translates to tasks that have more economical value. So at Adaptive, we help enterprises have the right tools to build these agents and put them into production. And to do this, we use reinforcement learning. So reinforcement learning enables companies to specialize models so that they are going to deliver better performance at a better cost efficiency, and also are going to be able to continue to learn in the future from the usage that they actually observe with the models. A good way to view this is that if you think about models, there is always a cost-to-performance ratio, which is essentially a compromise. For a given level of cost, you have a given level of performance, and that depends on the size of the model and the reasoning effort that you put in. And what's interesting is that with a generalist model, that frontier is fixed. But by specialization, you can unlock a new frontier where either you have a level of performance that you consider acceptable today, you are happy with the performance of your model, but you want to pack that into a smaller format that's going to be more cost efficient. With a lot of companies we work with, like AT&T, for instance, we see cost savings on the order of 50 to 90% compared to just using GPT-5 or Gemini or Claude off the shelf. And the other way that you can take this is that you can say, look, I don't care as much about cost, but I want to achieve a new level of performance, teach the model to do something that it cannot do today. And when you want to do this with specialization, we can enable the model to learn new tools, to combine new planning of much more complex, tasks. And this is something we see a lot with enterprises wanting to move from assistive model to models that actually, are able to complete tasks on their own. And with really the goal of getting beyond, frontier performance and having models that are going to perform better than the GPT-5 or Gemini of today. This is something so we provide enterprises the tools to do this. We essentially provide a platform that they deploy in their cloud, on their premise, to do all of this that enables their data scientists to have access to reinforcement learning library that they can use, and also run inference very efficiently, all of that. I'm not going to go too much into depth on this. I think that's pretty much covered it. I think it's good to illustrate, to talk a bit about some of the work we have been doing with companies. And we give an example with something that we are doing with SK Telecom, which is a big telco in South Korea, as the name might indicate. At SK Telecom, they have this use case on customer support, which is essentially a guardrail. They want to review messages, whether they are compliant or not with policies. And this is a guardrail that applies not only to what the user sends to the contact center, but also the other way around, what the contact center agent is sending to the user. Like it's kind of both ways. So very high volume, and you want to catch this very quickly because you are on the phone. So you need, if something wrong happens, you need to stop it very quickly. There is a latency issue here. And what's really interesting is that out of the box, obviously models like GPT-4o, 4.1, or Claude perform actually quite well on this task, and to a level that is acceptable, but they cause a lot of problem in terms of costs and latency, because these models are actually surprisingly slow. Like if you look, even 5 are actually quite slow. You are looking at a few seconds to get an answer out of it, especially because to get to this level of performance, we need to have some reasoning of the model actually thinking about, how do I, what is in this message? What does it, how does it relate to the policies, and all of this. They wanted to use open models instead, and small open models, and so they looked at Gemma 4b from Google. The reason for Gemma, by the way, if you are curious, is because this task is in both English and Korean, which actually is quite a challenge nowadays, because for languages models in general are quite good at European languages or at English, obviously, but as soon as you go to languages with different alphabets, like Korean or even Mandarin, the performance honestly falls off a cliff quite a bit. And out of the box, actually, Gemma performed really poorly. It performed very close to random performance. It wasn't something they could put in production. So they use our product adaptive engine to tune with reinforcement learning, using synthetic data, and they were able to get a model that's 4 billion parameters, and that's on par in terms of performance with GPT 4.1. Now, what's really exciting is that now we are at the level of performance that we want, to complete this task, but we have much better we have a much better performance to cost profile. So firstly, because the model is much smaller, now we have a 7x latency reduction. So we go from a few seconds to get an answer to getting the answer in hundreds of milliseconds. And this is really important when you are on the phone. In that case, this is a guardrail where you want to stop the conversation if something wrong happens. But we also have use cases where the model is actually speaking on the phone to a user. And so you don't want to have a long blank. You can try this on the phone. If you leave a blank of even 2 or 3 seconds, that doesn't sound like much, but it's extremely awkward, actually, on the phone. When you try it, when you try demos, you realize, something is really wrong. So you really want that speed, and here this is made possible by going to a much smaller model. Obviously, you could also consider using a model like GPT-5 Mini or GPT-5 Micro. And I didn't want to overload the slides, but actually these models don't perform well enough. The problem is that, yes, they are faster, but since they are still generalist, actually their performance falls off a cliff. And in that case, it wouldn't be acceptable to put them in production. You wouldn't get what you want out of it. The other aspect that is really exciting in that case for SK Telecom is that this is a use case with very high volume. This runs over every single conversation that their human agents have on the phone with their customers, and their customers is all of South Korea, so it's gigantic customer base. The cost when you run this on GPT-5 are enormous because you are talking about trillions of tokens that you are going to infer, nearly on a monthly basis. And compared to using an off-the-shelf model, in that case, we are at 1/10 of the cost. So this is a quite extreme example where there is extreme cost compression from running such a small model. But very often, we find figures in the range of 50, 70, 80% cost savings on most use cases, which is obviously quite significant now that models are running through trillions of tokens, which means millions of dollars, really, in terms of cost savings. That's it. This is what we do at Adaptive. We provide enterprise the tools to do this sort of stuff. People use us at companies like AT&T, SK Telecom, global airlines, for everything from customer support, enterprise search, fraud detection, employee automation. There's a very wide range of use cases that their data scientists are using us for. If you are interested in this, happy to talk afterward next to the stage. Thank you very much, and have a good after party.